Next one is we are going to see yesterday last class while we were seeing about the applications of DSP, we were seeing about the eye diagram, right? So I just want to give you some more details about the eye diagram. So we are going to see one module where you can see the eye diagram in a very clear way. We are going to send a normal signal and we are going to receive the same signal. We are going to plot the eye diagram for transmitted signal and receiver signal, and you will be able to clearly see how the received signal eye diagram is very, very poor. Okay, so this is the program which is going to do that. See here, I am creating a filter span 10 roll off factor. I told you we'll be using raised cosine pulse that has a factor called alpha. I hope you remember alpha is varying from 0 to 1. I told you that today. So I'm keeping the value of alpha as 0.2 and I'm defining all the parameters. Okay, so I'm defining the bits per symbol. I'm going to use QPSK. Okay, so see here, I'm going to use QPSK. I'll be using 4. I'm going to group 4 bits at a time. So 4 bits will be called one symbol. Okay. Now I'm designing a raised cosine filter using the roll-off factor, the span, and SPS. Okay. And then I'm going to generate a random signal. I'm going to generate a random signal with the 5000 length. Okay. And because I'm going to transmit this signal only using the QPSK. Then you see I'm modulating QPSK using the random data. I'm giving M. M is the number of things I'm going to group. M is 4 here and the phase offset. The phase offset in QPSK, the angle between each symbol is pi by 4. It is called as phase offset. Pi by 4 is 45 degrees. Okay. And you see I'm transmitting, I'm modulating the signal and I am transmitting it. Receiver end, you see, I'm finding out the EB by N naught. I'm adding AWGN to the received signal. In the receiver, I'm going to filter the signal using the same filter, and then I'm going to demodulate using the PSK demodulation, and I'm going to plot and see what is going to happen. Okay, so when we run this module, and see the answer here. This is the scatter plot. You can see this star is going to be the ideal point where your the signal has to be, and the transmitted signal is green, received signal is black. It is represented in black, and both are around the star. So I don't think there's a problem. But definitely it has to be exactly on the star, which is not possible, right? So definitely, so we have got the signal because we are adding random noise. See, we are adding AWGN, right? So when you add AWGN, the constellation will be shifting